In this video, I'm going to show how I created these traffic lights. These are intended for a G-scale outdoor model railway. They were created using FreeCAD and 3D printed. Then, in a future video, I'll show you how to control them using both a Raspberry Pi Pico and a custom Arduino-like PCB. I created the design in FreeCAD, which is a free parametric computer-aided design tool. It can be a bit daunting when first learning FreeCAD, but it's a powerful tool which is open source and without some of the limitations of the free versions of the commercial alternatives. I've already created a video for getting started with FreeCAD, so I won't be repeating the introduction, but I will be explaining everything as I do it. These traffic lights are based on a UK design. I've created these to scale, but there are some compromises between the model and how traffic lights are made in real life. This is a compromise between what can be achieved on a 3D printer and to make this rugged enough to be able to use on an outdoor railway, which will be open to the elements. There is a very long document under the UK legislation which shows the required dimensions, etc. I've based this on those and converted this to G-scale using a ratio of 22.5 to 1. One of the compromises is that I've used a straight post for the stem. Many traffic lights have a bend in the stem, but that would be hard to create using a 3D printer. And some traffic lights do have straight stems anyway. The main difference is that I've merged the stem and the light module into a single unit, whereas the light unit is normally mounted using small brackets. To try and recreate it exactly would mean having a very small joint which would be prone to getting damaged outdoors, and it would be very difficult to run the wires through. Start by creating a new document, then I'll be switching to the part design workbench. Now create a new body, and inside that body I'll create a sketch which will be on the XZ plane. So this will be used to create the shape of the top of the traffic light as if you were looking from above. I'm going to create this using the polygon tool, which is here. And this will be the housing for the light. I'll just draw roughly the outline starting at the reference line, and then we'll use the constraints to define this more precisely. So you can see 12 degrees of freedom, and now we're going to start applying constraints to tie it down and remove those degrees of freedom. Here's the constraints. I'll start by using the symmetry constraint, and this will create symmetry around the central line. So this will essentially position this line in the center. Then repeat the same for this top line up here. Now set the length of this bottom line. This is going to be the front of the light unit. The face at the front will come out an additional 2 millimeters. I'm using 18 millimeters here for the width of this. Set the length of the back as well, which I'm going to set at 10 millimeters. Now you can see that the shape has been quite badly distorted. This will be corrected as we add additional constraints. I'm going to add vertical constraints to these two lines here. Sometimes the vertical constraints, they do become redundant and we may need to remove them, but we can do that later if required. Just keep an eye on the solver messages, which will tell you how many degrees of freedom we've got and if there are any redundant constraints that need to be removed. I'm now going to set the height, which is actually going to be the depth of the traffic light. This needs to be between 2 points, so I'll choose these and set this to 12 millimeters. We've still got 3 degrees of freedom left. I haven't yet tied this bottom line to the center point, so I use the height constraint and go from the center point to this one and set that to 0. I'm now down to 2 degrees of freedom, so if I just try moving some points around and see if we can find out where they are. It looks like I've not set the height of these two vertical lines yet, so I can do that first using a height constraint against one of the lines. And I'll then use the equality constraint to make the two lines equal. That's now gone green, showing that this is fully constrained, and so now we can close the sketch and go back to the part design workbench. We can have a quick look round. It's a 2D shape at the moment, and then we can use the pad tool to extrude this and turn it into a 3D shape. I click pad, and then I'm going to set the pad distance to 45 millimeters. The pad has gone in the upwards direction, but I think it's going to be easier if I pad it downwards and then we keep the top as the reference plane. I've reversed that now, so this will make it easier when I want to do things relative to it. I can have a quick look around there. So I'd like to hollow it out now. So I'm going to click on this face, which is the side I want to hollow it from. And then I'm going to use the Make a Thick Solid tool. It's this icon here on the toolbar. And as you click that, you can see it hollows it out. I want the thickness to go inwards to keep the outer dimensions the same as I've set. So if I click that, it will do there, and set the thickness to 2 millimeters. I'll be creating a separate object for the front of the lights, which is going to overhang, but that's the main body head part of the light done. I'm now going to create the stem. This should actually be completely separate, but for practical purposes I'm going to join the stem to the head of the traffic light. Click on the top face. I'll use that for creating another sketch. I'm going to create a circle on here. I can set its radius using the constraints to be 4 millimeters, which will give me 8 millimeter diameter circle. I need this circle at the back of the traffic light, so I'll just move it up there. And to set the distance between this circle and the vertical line to be 0, so that it's on the vertical line. And for the height, I'm just going to judge it based on the diagram. So I think that's roughly about the distance I want. If I just set the height, and that works out about 14.5 millimeters. So I'll just accept that for now. And then I'm going to draw another circle just to get an idea of how this will look when I hollow out the stem. So I'll actually be deleting this circle later, but for now I'll just set this to 2 millimeters, and we can see how it fits against the traffic light, and it needs to be further down because that's not going to allow the wires to go into the back of the thing. So that's actually the sort of position I want there. This is about where I want the hole, so that will allow the wires to be fed into the back of the traffic light. I can move the larger circle down to 13 millimeters. Actually, say 13.5 might be a little bit better. Let's try that. Yeah, so with that slightly higher, that will provide access into the back through that hole. Now delete that smaller circle, we'll deal with that later. The large circle is fully constrained, so I can close that and we'll go back to the parts workbench. now pad this down by 140 millimeters, which is 45 millimeters for the top of the traffic light and then 95 millimeters for the stem. I'm going to create a hole up through the stem. I could have done this earlier, but then the hole would have gone through to the top, and I want this to be a blind hole. So I'm going to put it on this face here and then create a new sketch. I'm going to add a circle and then set its diameter to 2 millimeters. So its radius to 2 millimeters. And then I'm going to define this circle as external geometry so that I can use that as a reference point. If I select the two center points and use the point constraint to join those together, that's fully constrained. I'm not going to use the hole tool here, which is one of the options, but instead I'm going to use the pocket tool, and then you can use this to set a depth. I'm going to use the full length of the stem less 2 millimeters for the top. So that's going to be 138 millimeters. You can see the hole goes through the stem and into the top of the light. I do just want to make it a bit more open inside the top so that you can get the wires in easier. I'm going to create it on this internal edge and create a new sketch. And to switch to wireframe mode so that we can see where the sketch will be, because otherwise it's obscured by the top of the traffic light. And create a new rectangle, and this will create a groove down which we can run the wires. Create a symmetry constraint around the vertical line, and now we've got a redundant constraint that needs to be removed, and that's the horizontal constraint. So if we just remove that, we can continue. And now I can fix the dimensions of the rectangle. I set this length here to constrain it there. I'm just going to round it up to the 4 millimeters, which is the width of the hole. I need another reference point here to tie the vertical constraints next to. I'm going to use the external geometry against, say, this line. Just choose any of the appropriate lines, and now I can use that as a reference point. So if I set vertical constraints there, and then the length of the rectangle, and now it's gone green, so it's fully constrained. And now I can use that sketch to create a pocket, and the length of that pocket wants to be the 45 millimeters less 2 millimeters for each end. So that's 41 millimeters. I need to set that to. Just looking to see if it's going in the correct direction. So if I try reversing that, and you can see actually it appears there, so that's better. So I can accept that. And I'll change now to the shaded view, and so you can see that the hole from the stem is now open, so we've got a channel running down the top of this light that we can run the wires down. So that's the main part of the traffic light, the body and the stem complete. I'm going to create the face now for the traffic light. I'm going to create it as a separate body, and that way we can put them next to each other, see how they interact and print them separately as two separate objects. So I'm on the part design. I'm going to go to tasks and create a body, and then I'm going to create a sketch on that body, which is going to be on the XZ plane. So this is where the reference we've got before. We do the XZ, then we'll see that that's right in front of the existing body. Can create a rectangle which will be padding out, which will go inside the traffic light. It'll be roughly there. And we can use this plane, the points, as a reference point for the constraints. So if I do the height first here, so this would be 2 millimeters, which would be the distance of the outside of there. However, because of the way we're going to 3D print them and want them to be able to insert into each other, I'm going to take the entire dimension 0.5 millimeter smaller. So I'm going to put 2.25 there. And then the length of this will be the 41 millimeters, the inside dimension, less a half, so it's 40.5. So that's almost right. And then for the width, I'm going to use the symmetry first. So create the symmetry around this central line. This has come up with a redundant constraint message, which you get this when you create symmetry on something that's also got a horizontal or a vertical constraint. So if we could select it here, could select it there, or we could select it down there. It's all the same, and we just press delete. So that's that one gone, and it's got rid of that warning message. And then the last one is the dimension here, which should be 14 millimeters less 0.5 millimeter, so that's 13.5. And now that's fully constrained, so I can close that. You can just about make out the white line of the shape. Just turn around slightly. What I'm going to do is pad it, but I'm going to bring it out. When it's actually assembled, it will go in, but I'm going to pad it outwards. And by 4 millimeters, that's the distance I want it to be able to go inside the head of the light. Then I can use this surface to create the actual face. So this would be flush with this yellow area here when it's actually assembled. I can just create a sketch on there. And this one is going to be a bit bigger, so I'm going to have it overlap around here by 2 millimeters. So if I use the dimensions, if I use it from the same reference point, so I click the wrong one onto the height on there. So this wants to be 2 millimeters larger than the overall face that we've got here. I'm going to create the symmetry around here, and as before it's come up with a conflicting constraint, so says constraint number 5, find it there, and then delete that, and that fixes that problem. The length here is going to be the 45mm of that plus 2 at each end, so 49mm. And the width is going to be based on the 18mm plus 4mm, that's 22. And that's fully constrained. We can close that and then pad that out by 2mm, which is the width of the face. This is a separate body to this one, and although they're almost touching, they're completely separate. So the question is, do I curve these edges or not? And many traffic lights don't, but I've noticed some signs do. I think it looks slightly better if we create a bit of a curve in around this edge, and in FreeCAD that's called a fillet. So we've selected that edge, it's popped up on our tasks there, or it's the one on here, make a fillet, and I'll just set it to 1mm, which is quite a very small curve, so it's a bit of a compromise. It just doesn't look as, don't have the sharp edges. We can repeat that for all of these. Can do it as a single operation. And there we go. I think that looks a little bit better than when it's got the straight corners. You look at the body now, it shows you all the tasks that we've been doing. So now the next thing is to put the holes for the LEDs to go through. So I'll create another sketch on here, and I'll draw 3 holes. Three circles. Use the circles constraint to constrain these. So these are 8mm LEDs, that's 4mm radius. We can just set one and then use the equality constraint to make them all the same size. The advantage of doing that is that if you realise that the LEDs need to be slightly different size, then you can just change it once and it'll change it for all of them. Make these line up against this point, and we can do the same for the others. We can do them relative to that one, now we've set that one, or we can do them relative to the top. We can set this top one a distance of 7.5mm, which is the distance from the top of the body parts, not including this overlap, down to the centre of that. And then each of these should be 15mm apart. Okay, and then that would be the same at the bottom of the top. Fully constraint, so we now can close that and we can create a hole using this. Again, we'll move back to the part design. We use the pocket rather than the hole tool. We can set the dimensions, which would be 4mm of the back one plus 2mm of the front one, or we can just do through all. As you can see, it goes through all the dimensions there. That's the basic shape done. We could export, 3D print that. I'm going to add hoods to these. They're optional because you could just print off and use this as it is, and this HUD is going to stop the sun's glare. It's quite common to see these on traffic lights, but I originally didn't want to include them to make it so that you could see the lights better when standing from above, but I think they make it look more realistic, so I am going to go with them. I'm going to create it on this face, which is the front. Just create a sketch on there. Cancel stuff. Set the face and then create a sketch on the face. I'm going to create these as full circles and then cut away to make them look as so they only predominantly cover the top. So just I'll create one for each of these. I'll just do, and then we'll look at sizing them. I'll size the top one and then use the others to take the size from there. So I want it just a little bit wider than the existing one, so if I go for 5mm, and then this needs to be at least 2mm extra to give it the strength it needs, so let's go for 7mm there. And let's just have a look at how that looks. So we've got two circles, we need to make them, yeah, the vertices are roughly the same place, but there we go, just to define them. Put that as being a distance of 0. And then this to here, it should be 7.5mm. There we go. So I think that should look okay. And then we can do the equality between that one and that one, between that and that, and the same here. And just need to select the 2 points there, put them together, same there, and then we can position those relative to there, and do the same distance that we did previously, which is 15mm. Those so looking at these are a bit too big, they're coming too close together, so I'm just going to adjust this top one, and then the rest, because I've used equality, should be the same. So at the moment this has got 5mm. I'm going to make it 4.5, so it's much tighter around there. Then I think this could be 1.5 on top of that. I think if I go down to 1mm, it's going to be too thin and not strong enough. So if I go for 6mm instead, yeah, I think that's going to look a lot better. So they're all fully constrained, so I can close that, and then if I pad these out, 10 millimeters. As you can see, they've all come out the same. So what I need to do now is just to cut out a cross section across the bottom of each, so that their hoods are only really over the top. They're just going to come across here. I'm going to do this using a sketch again. I'm going to put the sketch on this face, I think. Let's just rotate this round. So, although I'm not actually attaching it to these are the parts it's going to be affecting. Start by creating a polygon, showing roughly what I'm wanting to achieve, which is basically a triangle like this. I need one of these for each of the shapes. So I'm just going to work out roughly where I want it in here, and then we can tie it down a little bit better. You can see I'm just judging this, but I want this small area to be flat at the top, which you see will be this here, and then gradually come back down. So I need this a bit lower, but it's probably about there. So now I can constrain this. That's 16.5. It's because there's see what's happened. It's because I chose that surface, it's actually 90 degrees, so when I try and do a vertical, it's horizontal and vice versa. So that's why it should be like that. So let's put it this way around just to make that easier. So we can set these as being vertical, set these as horizontal. Set all these heights to be the same. I can just do it relative to that one, relative to that one. Set this as 3 millimeters. That one as 14. Back into that. Just see if this one looks like it. Oh no, so that needs to be the length of that needs to be constrained as well, so set that. So it's 9. And now it should be able to just copy this one to be like this one. So we could just do those equal. Those equal. The spacing between these should be 15 millimeters. And then the same for that to that. I've just got 2 degrees of freedom. Shows them. Yeah, so I need to just set the distance between there and there. It's 15 as well. And then the same here. Hopefully that should do it. Yep, so that's all fully constrained now. So I can close that. And now I can use the pad to cut that out. I do through all, and it's going to go all the way through. Just have a look at how those looks. That looks about right. So okay, save that now. So there we are, that's now finished. We can export these as our parts. So the thing about exporting from FreeCAD is you always need to choose the last part that's shown here, because that's encompasses all the changes above it. So for the stem we'd use that and then use the file and export, and for the body use that file and export. Export it as an STL file ready to put into your slicer and then for 3D printing. But before I do that, I'd just like to just demonstrate one of the things we've done. So we created these two as bodies. Let's show you that we can have a look at these two separate bodies, moving that in so that we should be able to see how it will fit. You can do that by looking at the value of the body and this placement option here, and this is on the, we're looking at the side, this will be on the Y plane. So if I try changing that by -4 millimeters, so 4 millimeters, and then we can see that's it, and that's how it will look when it's joined together. And I haven't actually changed, they're still two separate parts. You can still select them, print them separately, edit them separately, but when you look at it, it shows you how they will look when they're finally printed. That's quite a nice little feature. So I'm going to leave FreeCAD now. I've exported these already, and I'll just show you a few tips of help when slicing these ready for 3D printing, how I've chosen to do these. So I've loaded the main part, the traffic light, into Cura, which is what I'm using as my slicer. You can use whichever slicer you prefer, and this is just going to show you some tips about printing that I find for my printer and using Cura. I want to print this upside down, so I'll choose the top as the face to put on the base plate. This will reduce the amount of support scaffold needed, but also importantly make sure it doesn't fill in scaffold inside the stem, which would stop us from running the wires through it, or at least we'd need to reopen that. I'm going to turn on brim support for layer adhesion, which is going to help it stick. I'm also going to slow the printer down to about 40 millimeters per second instead of 60 millimeters per second, which is what I usually use. This will reduce the speed of the movement and vibrations when it's printing, so should make the print more reliable. Finally, I'm going to show you a trick I use for models that are particularly tall and thin, like this one. I want to increase the base material to help with the adhesion. So I'm going to just use some basic shapes and place them on the bed, and that will help increase the amount of brim that I'll be using. So this is the file I've got, which is just a padding. It's just a square that's 1 mm high, and it results in this really large brim. I'm going to create multiple copies of this all round the traffic light, and that should give me a nice wide brim. So it's created some copies. I'm just going to move these around so that they're all around the traffic light. I'm only going to do this is only on the first layer it's going to affect, so it's not going to use a huge amount of material or too much time to do it. It's going to add a bit of time, but not too bad. But it will help with the first layer adhesion, which is particularly useful on the printer I use. It tends to stick and gives it a bit more stability while it's printing. If I now slice this, you'll be able to see through the preview what it's done. So just slice and save this. Now I can use the preview option, and there you can see all the layers. If I scroll right down, you can see this is just a nice big layer at the bottom, the very first layer, and that's going to certainly help with adhesion and with it printing. I've then created a base to mount them for this demonstration. The base is, however, not to scale. The lights are intended for an outdoor railway, but this gave a quick way I could connect these up and test them indoors first. One thing I've added in the later revision are hoods. These are normally included on traffic lights to reduce the reflection from the sun. Initially I left these off to make it easy to see the LEDs when standing above the height of the models, which is for when they're mounted on a railway on the ground. But then I created a separate face with the hoods, as that looks more realistic. Both versions are available to download from Thingiverse. This video has shown how this has been designed using FreeCAD and then 3D printed. In future videos I'll be showing how they can be controlled using both the Raspberry Pi Pico and with an Arduino-like circuit, creating your own custom printed circuit board. If you're not already subscribed, then please do so and click the notification icon to get notified of my future videos. Thanks for watching, and I hope to see you again on a future video.